Greetings and welcome to Lecture 4.2, Addition and Subtraction with Decimals. So let's take a scenario when you might need to add decimals. Perfect situation is money. Money works with decimals. So suppose we earn $8.50 an hour and we receive a raise. Woohoo! And it's $1.25 an hour for our raise. What is our new hourly rate of pay? Well, there's actually two methods of doing this. The first method is to convert our decimal to a mixed number, and then maybe even we have to convert it to a fraction. But I think in this situation, once we get it into mixed number notation, we'll be able to add since we already know how to do that. So we have 850 is 8 and 50 over 100, and 125 is 1 and 25 over 100. 50 over 100 plus 25 over 100 is 75 over 100. 8 plus 1 is 9. So our new rate of pay is $9.75. Now, method 2, I think, is a lot faster. What you do is you just line up the decimal and then you add like normal, bringing down the decimal exactly where it is. So 8.50, 1.25, line up the decimal, 0 plus 5 is 5, 5 plus 2 is 7, bring down the decimal, 8 plus 1 is 9. That's it. All you need to do is line up the decimal. Let's work through an example using method 1, which is converting it to mixed number, and add the following decimal numbers. So we have 25.43, 2.897, 379.6. So we're going to convert the 25.43 to 25 and 43 over 100. The 2.897 is going to be 2.897 over 1,000. And the 379.6 is going to be 379 with 6 over 10. We do need to find common denominators. So the 100, I'm going to multiply it by 10, and the 10, I'm going to multiply it by 100, giving me a total of 406, 1927 over 1,000, but 1927 over 1,000 can be a mixed number in itself, 1 and 927. So what's 1 plus 406? 407. So our final answer is 407.927. Now taking that same problem and using our second method where we just align the decimal, let's go ahead and add it up. As you see, the back side of the decimal doesn't quite add up very nicely, but that's okay. We can just use some placeholders. So we're going to use our zeros as our placeholder. So 0 plus 7 plus 0, 7. 3 plus 9 is 12, carry the 1. 1 plus 4 is 5, plus 8 is 13, plus 6 is 19, carry the 1. Bring down the decimal. Now we have 1 plus 5 is 6, plus 2 is 8, plus 9 is 17, carry the 1. 1 plus 2 is 3, plus 7 is 10, carry the 1, and then the 4. 1 plus 3 is 4. See, the only difference is that we do want to keep these placeholders and align all of the decimals up. Now, if you can see it without the placeholders, then you don't need them. I particularly like to use the zeros for placeholders. Now let's try an example with subtraction. Let's subtract 39.812 and 14.236. So what I'm going to do is align them with the decimals right up on top of each other, and once I have them aligned, I'm going to look to see if I need any placeholders. And in this case, they each have 3 decimal places to the right, so I'm okay, I don't need any placeholders. So let's go ahead and start the problem. And first and foremost, I'm going to treat it just like a regular subtraction problem. So I do need to borrow 1. And now it's 12 minus 6 is 6. The 1 became a 0, so I need to borrow again from the 8. 10 minus 3 is 7. The 7 is now, or the 8 is now a 7. 7 minus 2 is 5. Bring down the decimal exactly where it is. 9 minus 4 is 5. And 3 minus 1 is 2. That's it. So the really only difference is we line up the decimal and bring it down when we need to. Let's try another example. This time addition. And it looks like our decimals aren't going to align. So what I'm going to do is use my placeholders. And 8, a whole number 8 is just going to be 8.000. I still have 0.002. 3.1 becomes 3.100. And the 0.04 becomes 0.040. Again, the zeros are just placeholders, so I'm going to add the columns. And I end up getting 2, because 2 plus zeros are 2, 4. The next column is a 1. Bring down your decimal. 8 plus 3, 11. So my final answer is 11.142. Now I'm going to run through a subtraction problem. And first write it down. Again, aligning the decimals. 3.0814. And again, for me, I like having placeholders just so I can immediately see what I have in front of me and what I don't. So it does hold that place. And in this problem, this is really great because I'm going to have to borrow. And if I had error there, I can at least, in the sense, I can go to the 9 and borrow and then keep borrowing back from the other zeros, which become 10. So let's say I need an 8 from there, because I'm going to end up giving it to the 0, which becomes a 9, giving it to the 0, which becomes another 9, and giving it to the last 0, which is now a 10. 10 minus 4 is 6, 9 minus 1 is 8, 9 minus 8 is 1, 8 minus 0 is 8, bring down the decimal, and 5 minus 3 is 2. So same methods that we use for whole numbers, except line up the decimal. It will make life a lot easier. Now, of course, life isn't made up with just numbers and a given problem. We have to decipher problems with English. So subtract 3.09 from the sum of 9 and 5.472. Well, I'm going to take the sum, because if you think about it, it's from the whole entire sum, so I can have parentheses there. And it's say parenthesis 9 plus, I'm just setting up my problem, not actually doing the math yet. And I'm going to subtract 309 from the sum. So if it's taken from the sum, it's going to be the sum minus 309. So now that I have my problem set up, I'm going to treat it individually, parentheses first, 9.000, I'm just getting my placeholders there, plus 5.472, that's going to be 274 point. 9 plus 5 is 14. But I still have to subtract this 309. Subtract 3.09. Again, a placeholder just to hold my place there. 2 minus 0, 2. 7 minus 9, I need to borrow, is an 8. 3 minus 0, is 3. And 4 minus 3 is 1. And 1, bring it down. So my final answer is 11.382. Right? Same steps, just line up your decimal and you'll be okay. Now, of course, we don't always have just positive decimal numbers, so you're going to treat the positive and negative combinations the same exact as you would with whole numbers, except we have a decimal. So let's try the first problem. Negative 4.75 plus a negative 2.25. They have the same sign, so I'm just going to add them. 5 plus 5 is 10, 7, 8, 9, 10 again, and then 5, 6, 7. They share the same side, so it's negative 7.00. If they have opposite signs, just like in whole numbers, I'm going to take the difference and give the sign to the larger. But when I write this out, definitely I need to line up my decimal. 3.42, I'm going to subtract the two numbers and give the sign of the larger of the absolute value of the numbers, which would be the 6, so it is negative 3.47. We actually use subtraction and addition of decimals all the time because our currency is in decimals in essence. So let's take an example. You and a friend go out to lunch and the bill is $15.64. You pay with a $20 bill, and for change you receive 4 $1 bills, a quarter, a nickel, and a penny. Was your change correct? Well, first let's figure out what the change should have been. So 20.00 minus 15.64. Let's borrow. So I have 6, 3.4, and that's 1. So I should have received $4.36. So I received $4 bills, so that's going to be 4.00. I received a quarter, that's 25 cents. I received a nickel, 0.05, and 1 penny, 0.01. Add them all up. I have 5 plus 5 plus 1 is 11. 1 plus 2 is 3. And bring down the 4. I did not receive the right change, or we didn't receive the right change. We should have gotten one more nickel. So this is where you might want to check every time you get some change to see if indeed it was correct. So let's try one more example. So faster than. I have 4 female runners that ran a race the same length. Florence Griffith Joyner in 1998, she ran 10.49 seconds. Carmelita Jeter in 2009 ran that race in 10.64 seconds. Marion Jones in 1996, 10.65 seconds. Shelly Ann Fraser-Price in 2012, 10.70 seconds. So let's use that information to determine how much faster Florence Griffith Joyner ran in 1998 than Shelly Ann Fraser-Price did in 2012. So it is a subtraction problem. I'm going to take Shelly Ann Price's time of 10.70 seconds, and I'm going to subtract Florence Griffith Joyner's time of 10.49 seconds. We're going to see how much faster Florence Griffith Joyner was. So 1, 6 minus 4 is 2. 10 minus 10 is 0. Wow. So not very much faster, 0.21 seconds. And to me, that's a blink of the eye, but to runners, it makes all the difference in the world. So that's it for this video. Until next time, be seeing you.